Welcome friends, in this one let's take a look at some vector basics, so part one of a pretty big topic. So what is a vector? We'll define it. A vector is a directed line segment. That's a good definition at this point. So how do we depict a vector in three-dimensional space? Basically think of it as an arrow. It's a directed line segment. So as an example, here's a vector. It has a definite point, it stops at a particular point and has a particular length and a direction to it, you see? Here's some other vector. These two vectors would be considered different because they're going in opposite directions. For example, even if vectors go in the same direction, like the shorter one and the longer one, they're still different because the lengths are different. You might have two vectors, for example, like one is going this way, as an example, and then you make a copy of it, and put it this way, but then you flip it some number of degrees this way, for example. So this vector, the copy of this one, and the one here, those are different because they're pointing in opposite direction. Next, let's define the concept of what we mean by equivalent vectors. Again, let me take a coordinate system here. That's a copy of the same object, put it over here. By equivalent vectors, we mean vectors that point in the same direction and have the same length. So equivalent vectors point the same way and have the same length. Let me draw here a picture of a vector. So here is one. Then this is what you can do. You can make basically any number of copies that you want of that vector. It doesn't matter where they are positioned. These are all considered to be equivalent vectors because they both will all rather point in the same direction and have the same length, regardless of where they are positioned in our 3D coordinate system. Let's move on here. So another thing that we can cover is the following then, friends. Unit vectors are used to build up other vectors. Set a copy of our coordinate system again. So right now I'm going to do that. Here we are, that's our coordinate system. And where are unit vectors found in the coordinate system? They run along each of the directional axes there, along the x and y and z axes. So you might depict them. Often they're depicted as thicker arrows whose length is 1. So in other words, look this carefully. This here is a unit vector. In other words, its length is 1. The one that runs along the x-axis is often given a special name I. Because it goes along the x-axis, it has only a component along the x-axis and no y or z component. So for that reason, often this is what we do. Besides just doing this, we say that it's equal to the following. We use brackets, angled brackets. Some people use parentheses. You use angled brackets, then you put 1 because it's 1 unit along the x-axis, and then 0 because it's 0 units along the y-axis, and then 0 because it's 0 units along the z-axis. And on top of it, some people also sometimes place the following, a little arrow, like that, to indicate that it's a vector because vectors are represented with arrows naturally enough. I won't do that just because it's easier to type without the arrows. Besides this one, we can also then define a unit vector, a vector of length 1 that goes along the y-axis. So you want to make sure it kind of has the same length as the one along the x-axis. Now this one is conventionally called j. And it has the following, what we call again components. Because it doesn't go along the x-axis, the x component is 0. The second component is 1 because it goes 1 unit along the y-axis. And the last component is 0 because it doesn't go along the z-axis. And again, if you wanted, you could put an arrow above it. And the last unit vector, as you can very likely imagine by now, is the one that goes up along the z-axis this way. So this one here, it's often called k. You can put an arrow above it if you want. And it has the following components. You can probably imagine them already, but 0 along the x, 0 along the y, and lastly, for example, 1 along the z-axis. Any other vector can be expressed as what we call a linear combination of these basic vectors of length 1 each. As an example, imagine the following, that I take a copy of just I, and I place it here, and then I take another copy of I, and I place it right here. That's representing the vector there that begins at the origin and goes to the tip of the second arrow as two separate arrows. But most people would actually just draw it this way in the first place. You begin on the origin and just kind of go over it to the end right here, you see? Because it's made of two shorter arrows, you would say that the green vector, we might call it V, is equal to 2I, where I is the unit vector. As you can see, it's just two of them, that's all. You might write this also as follows. You would say 2, and then you would put the vector I. Now I is 1, 0, 0. Then there's a basic property that allows you to distribute the 2 over to each component. So that would be basically 2 times 1, which is 2, 2 times 0 is 0, and then 2 times 0 is again 0. So that would be another representation of the same vector. Make a copy that goes along the z-axis this way. And then just, for example, again, stack up like some number of these, say 3 this way, okay? So this is like adding up 3 vectors of unit length along the z-axis. That basically goes from here up to here, the blue vector now. So you can see that the blue vector, call it W, is equal to 3k. It's made of 3 arrows, okay, of unit length. So this is equivalent to 3 times the vector, the unit vector along the z-axis. That would be 0, 0, 1. Then you're allowed to just distribute that 3 over to the 0, the 0, and the 1. So it's going to give you the final vector that looks like 0, 0, 3. So 3k is equivalent to just the vector 0, 0, 3. The 3k notation just stresses the fact that W is 3 times a unit vector in the z direction, that's all. And then imagine, for the sake of example, that we take only 1/2 of that vector. So it's about right there. You see that green arrow that covers only half of the red one? So maybe we'll call that the vector P is equal to 1/2 of j, the unit vector along the y-axis, which would be 1/2 of the following, 0, 1, 0. And then again, you can distribute that 1/2 to each component individually. So it's going to be 1/2 times 0 is 0, 1/2 times 1 is 1/2, and then lastly, 1/2 times 0 is 0. And that's another way of writing that same vector. So the big idea with unit vectors, remember, unit vectors are used to build up other vectors, just the way I've shown you. I'll leave it here. We'll pick up in another video. So thank you, friends. Please leave a like. Please subscribe. Thank you so much for watching. I will see you in another video.